Lopez, our science expert from Seton Hall, and we are to understand, Dr. Welcome, that there's something out there called a neutrino particle.
Yes.
What is this?
A neutrino is a subatomic particle, so that means it's smaller than an atom. And an experiment that was done in CERN, which is in Geneva, Switzerland, it's the European Organization for Nuclear Research, they sent a bunch of neutrinos from Switzerland to Italy, where there's a special detector. It's called the opera detector. They like fancy acronyms. And it turned out that the neutrino, which has some mass, was moving faster than the speed of light, which is a violation of all of the laws of physics that we know of. Nothing moves faster than light.
So what are the implications of this study?
Well, Albert Einstein, who we know is synonymous with genius, basically told us that c, which is the letter c from E equals mc squared, is the ultimate speed limit. Nothing goes faster than that. It's not set by any government or anything. The universe decided that no matter can move faster than 300,000 meters per second. And the implication that something moves faster than that can mean a bunch of weird stuff can happen.
Now, how do you see or spot something like this if it moves that fast? How do you isolate it?
It doesn't. That's the whole thing. It would be a violation of physics. So I'd be out of work, and everything I've been telling my students would be completely wrong. So this is why it was such a controversy when last September it was revealed that there's this particle that moves faster than the speed of light. Because then weird things start to happen.
Okay, does that mean that if things are moving faster than the speed of light, then things are arriving before they happened?
Yes.
So we can time travel?
Yes, you can time travel. Now, according to the theory of special relativity, you can time travel. Well, not really, but theoretically, you could time travel to the future, but you couldn't go back. Now, if you have a particle that is moving faster than the speed of light, you can travel back in time. So Back to the Future, the movie, would be possible.
So go ahead.
Well, my question would be, how do you utilize that knowledge? What do you do with it?
Well, if it was possible, then what you're both doing, talking about the news, you'd be able to, your future self would be able to tell your past self what happened in the future, and Matt would be able to tell his everybody about the weather a week from now to his current self right now in the present.
Did you just say that?
Yes. My future self.
Are we saying that Einstein is wrong?
No.
No.
It turns out that they did another experiment just about a month ago, and another detector called Icarus, also in Italy, and it turns out that neutrinos are not traveling faster than the speed of light.
Are we saying that Einstein is wrong?
No, he's right.
Wait, you get what I'm saying? I just went back. I tried to go back in the Back to the Future.
So here's my question. A lot of these scientists are on these federal grants and what have you. I mean, you guys sitting around, you know, just maybe we can do this or maybe we can do that, or we don't know if this exists, or just too much time on your hands?
Well, I mean, this is a measurement that they wanted to better understand what neutrinos do. But I mean, the result was just flabbergasted everybody. Everybody was completely surprised. So they did what scientists do. They revealed it. And then the news, the media, everyone picked it up and said, "Oh my God, Einstein is wrong. The genius is wrong. So what's going on?" But it turns out he's not. He's right. The laws of physics, what we're teaching everyone in school, is still correct.
Okay, so then what's the point?
The point is
of the study.
The point of the study was to understand how fast neutrinos were moving and to better understand how neutrinos behave.
And how do you actually send something like that? Do you shoot it with a laser gun? I mean, what? Does it go by spam mail?
No spam mail. So in CERN, they have the world's largest physics experiment. It's called a particle accelerator. They basically take matter, atoms, and they accelerate them around the loop very fast, near the speed of light, in a machine, and then they send them out very quickly. Yeah. And from Geneva to Italy, it was 700 kilometers away. And then once it hits there, they were able to detect how fast it was moving. So you can do that kind of experiment. And that's what they were trying to do to better understand neutrinos. But
is there an application for this science, or something in the future you're looking at to say, well, maybe we'll be able to improve this?
Well, neutrinos are found all over the universe. The sun is constantly sending us neutrinos, stars, and stuff like that. And we don't understand them too well. They travel close to the speed of light because they have very little mass. So what we're trying to do is come up with this thing called the standard model to understand all the building blocks of nature. There's still some problems there. So the idea was to understand how a neutrino worked. but it should not have traveled faster than the speed of light, and it didn't.
I
as far as we
understand
know.
that you have some information about Einstein's brain and the whereabouts.
So Einstein is he's been passed away in late 1950s, and
From Princeton, New Jersey.
From Princeton, New Jersey, and now all of a sudden he's a celebrity once again. Well, and his brain, which was actually taken out of his head when he passed away, is now on display in London, slices of it. So he's a celebrity again, and his papers have been digitized and put up on the internet right now so people can read them once again.
Dr. Jose Lopez, what's faster than the speed of light? Thank you so much for joining us today. You get it? I went Back to the Future there.